Hi, I'm delighted to be here, and I'm delighted to talk to you about AI safety, to give you some thinking tips that will help you think about AI in a way that helps us build a safer, more reliable AI future together. First tip, forget the science fiction. Science fiction is actually quite a dangerous distraction. So a lot of the tone there in the portrayal of AI has to do with personhood, autonomous entities. Instead, AI comes from humans. Like all technology, it is built by us, and all technology is an echo of the wishes of whoever made it. AI is human all the way through. Humans design it, humans build it, humans test it, humans create the safety nets for it. So there's a tiny sprinkling of computer science and mathematical stuff, and a lot of the human all around it. So what instead should you think about? Think about technologies that scale really quickly. If you scale up a wish without thinking about what you have asked for, you can end up in some tricky situations. So, first nugget, don't be distracted by sci-fi. Instead, think of AI as a useful tool. And if you're worried about AI being better than human in some way, let me remind you that all of our tools are better than human. If you think about pen and paper, cognitively, it's better than you. Otherwise, why would you use pen and paper to take notes? It's got better memory than you. A calculator multiplies 6-digit numbers faster than you do, and a bucket holds water better than you do. All of our tools are better than us at something. So what is AI actually better than us at? It's about writing software. Let me put this to you very straightforwardly. Computers transform inputs into outputs. That's what they're for. And with traditional programming, the way that you do that transformation, so you need some kind of recipe or model to go from the input to the output. And the way you make that is by coming up with the instructions, by thinking really hard about the problem and handcrafting that solution. But every now and then, it's really hard for you to come up with what those instructions must be. Think about taking an image and figuring out what's in it. Cat or not cat? That's your goal. What would you have to do with each pixel to turn it into the answer? That's kind of hard, isn't it? So how would you handcraft that recipe? It's hard to express what the answer should be, so how do you just come up with it? Wouldn't you prefer to go a different way? Instead of using instructions, wouldn't you prefer to say, here's a bunch of cats, here's a bunch of not cats, figure it out. Instead of using instructions, you would use examples. That is the essence of AI and machine learning. So if you want in just one slide what AI is all about, this is it. You express your wish with examples. You say what you want with examples, not with instructions. And so you would want to use this technology in situations where it's much easier for you to come up with the examples than the instructions. And it also means that you can start to automate tasks where you don't even know how you do it. You can't exactly say what you've done with each pixel to get the result. But it's really important for you first to be able to come up with the examples, but also for you to be able to say what it means to do your task well. So to wake us all up a little bit, we're going to have a let's be the project leader kind of game here. So what I need from everybody is for you to tell me, for each of these photographs in order, whether it does or does not have a cat. So you're going to shout cat or not cat for each of them. You're going to say the number, you're going to shout cat, not cat. So you can think of yourself either as the human project leader here or as the AI system labeling it as cat, not cat. So let's go with number 1. Cat, exactly. 2, not cat. 3, cat. 4, cat. 5, no, 6. What do you mean, maybe cat? That wasn't an allowable label. Big cat's not an allowable label. So is it cat or is it not cat? Some of you are saying cat, some of you are saying not cat. It's got to be one or the other. Well, see, here you realize that it depends on what the system is supposed to do for you. It depends on the point of the project. And for different projects, different answers are going to be appropriate. So I suppose I'll have to step into those big boots of the leader, the human decision maker, and I will tell you that the purpose of this project is to serve as a pet recommender. And so if it says cat, the animal has to be from the cat family and in its standard adult form, something that is safe to cuddle. Let's try number 6 again. Now everybody is saying not cat, and if you're still saying cat, take out more life insurance. So you see that the purpose of the system really matters here. There is no one objective answer every time. This isn't about Platonic forms. The objective is always subjective. And this means that a system that is built and designed for one purpose may not work for a different purpose. Similarly, datasets collected for one purpose may not work for another purpose. So always remember that the objective is subjective. It is up to the human leaders to come up with it. Now, next question for you. Which do you prefer in a worker? A reliable worker or an unreliable worker? You're feeling like this is a trick question. And it is. If you strongly prefer a reliable worker, watch out. This actually really depends, again, on the human leader, the decision maker. Because if you have a brilliant, intelligent decision maker, of course you want a reliable worker to reliably carry out exactly the instructions that they've been given. But what if your decision maker isn't very good at giving instructions? Well, then you're going to want an unreliable worker who does everything except what they're told, so that they don't go and carry out foolish instructions. Computer systems, technologies, including AI, are the ultimate reliable workers. They do exactly what they're told, and they scale very quickly. Whereas, by comparison, humans are a little less reliable. They've got a whole bunch of different motivations and incentives. They prefer to sit on the beach or play with their kids or go home early instead of just following instructions. And so the quality of the decision maker really matters when we get to these AI systems. They will do exactly what they're told. And if they pass testing, that means that they are simply delivering exactly what the people who made them asked for. So, next tip, strive to amplify the intelligence of a skilled decision maker, rather than amplifying foolishness. This means that whoever is going to be building this system needs to have some skills. If you want to really see where the essence of AI's danger, if you will, relative to traditional programming lies, let me spell this out for you very directly. When you are doing traditional programming, you have to come up with the instructions. It might take 10,000 lines of code, 100,000 lines of code maybe. And some human being has to worry about every single one of those lines and agonize over it. Whereas when it comes to machine learning and AI, there are actually only 2 lines there. There's a whole lot of other programming that the engineer has to do, but that's because the technologies are a little bit clunky to work with. But there are only actually 2 real lines there. Here's what they are. This objective, that data set, go. If you give each of these 2 lines as much thought as you would have given 1 out of those 10,000 lines, you're doing it wrong. You have to be much more thoughtful here. These 2 lines express everything. So it really matters what you choose to say here. I think of technologies based on data at scale, like the proliferation of magic lamps. And it's never the lamp that's dangerous. It's never the genie. It is the wisher who is unskilled, who doesn't know how to express their wish properly, so that the spirit of the wish exactly matches the letter. So we need to be really careful and think through what we are saying when we say those two lines. And whenever anything goes wrong with AI, it comes down to that: a poor choice of dataset or a poor choice of objective. Next, you've got to remember that mistakes are possible and they will happen. So what will you do when they happen? I really like this example on Twitter. So this is a tweet by BJ May. And he tweeted that his Nest smart front door system has locked him out of the house because it was protecting the residents from Batman. Here's the thing. Mistakes will happen. Humans make mistakes. Computer systems make mistakes. You should never forget that mistakes are possible, and you should think like a site reliability engineer, a person who keeps these systems reliable if you're ever involved with these projects. Plan for mistakes. What will you do when the mistake happens, not if it happens? And build safety nets. So here, luckily, the engineers had realized that mistakes were possible, and so you can put a PIN code in and get through the front door. If they hadn't thought of that, poor BJ May would still be locked out of his house. After the mistake happens is not the first time that you should start thinking that mistakes are possible. And we should never completely trust any system, whether it's based on humans or technology, or the combination. Now, AI lets you automate the ineffable. That means that even if you cannot express what those instructions are, you can still get it automated. That is so powerful. That's so incredibly cool. But if these instructions are so complicated that you can't even express them, then you shouldn't expect to read the instructions and from that know that the system works properly, because those instructions are just too long and complicated and, quite frankly, boring for you to grasp. So how will you know that it works? The same way as you know with a human student. Test them carefully. You don't know that your human student does calculus or French properly by opening their brain and seeing how their brain does it. I'm glad that we don't do brain surgery on our human students. Why would we want to do the same thing with our computer systems? Why not do what is sensible with complex systems like ourselves? Test them properly. Now, when it comes to testing, there's an easy way to mess up. Here's a little example involving my two cats, Huxley and Tesla, and some bananas. This is your training set. Now, with these systems, you need quite a lot more data than just 7, but we can use our imaginations. Imagine that this is what we put in, and then we train our system. There's some kind of recipe that happens. It's supposed to then output the label Huxley, Tesla, or banana. And then we're going to test it on some examples. So here's the examples. And ta-da, 100% accuracy, right? Perfect system. No. A much better test set would be a test set that the system has never seen before. Because things with good memories can memorize their way to a perfect solution. That is what overfitting in AI is all about, and that's what we want to avoid. And we avoid it same way as we do with human students. Don't give them examples they've seen before. If you give them examples they've seen before, you can't trust that they're not memorizing. So give them new examples and, find out that it's not doing very well. So always use pristine data for testing. Make sure that your system couldn't have cheated and memorized. And that's why you've got to get in the habit of splitting your data and leaving some back so that the system can have new things to be tested on. And a lot of mistakes that we see out there happen when people don't do this and forget that the point of computers is having really good memory and doing things quickly. Now, even if you were to get a perfect test score here, watch out. Avoid jumping to conclusions. Let's have a look at these images again. What was really precious to me here is the identity of my kitties. But what I didn't notice is that in the background of both my training set and my test set, whenever I had Tesla, there was a radiator. And whenever I had Huxley, there wasn't. So I might be tempted to conclude that from this great performance that this is an excellent Huxley-Tesla detection system. Meanwhile, all it's doing is finding radiators in the background. So I shouldn't have that arrogance of thinking that I understand what this all means in the background. Here's the thing. If these sorts of data are the only ones I'm ever going to use, and I want this system only to work in my apartment and only on data where Tesla and the radiator always coincide, who cares how it does it? It's going to do the job properly, and if I've tested it well on those data, it's going to continue to do the job properly. But I tell Google engineers they should pretty much tattoo this sentence on themselves if they're going near machine learning. The world represented by your training data is the only world you're going to succeed in. So you're going to do great in a world where Tesla and the radiator happen together every time. That doesn't mean that your system is going to work well anywhere else. So it really matters what the nature of your data is and that you have tested it where you need it to work. Now, machine learning turns patterns into recipes. That's what it's about. Let's think about machine teaching. We're using examples to express ourselves. Which examples? Those examples come in datasets, and datasets are pretty much textbooks for your system. And textbooks have human authors. So do datasets. Datasets are textbooks, textbooks are datasets. Both are collected and written according to instructions made by people. They are not objective. They don't appear independently of humans. They're authored by humans. And you've heard a lot about algorithmic bias. Let me remind you very quickly of its definition again. Algorithmic bias occurs when a computer system reflects the implicit values of the humans who created it. That will always be around, folks, because you can't separate the human out of technology. And even if we create systems that today are completely palatable to us, are we sure that in 500 years' time, our descendants won't think that we were a pack of barbarians for having the values that we did? So the human part is always going to be in there, but that's not an excuse for us to be jerks. Datasets have human authors. If the author is a horribly prejudiced individual, the student using the textbook will pick up that same prejudice. We should worry about that. Now, whose fault would that be if it happened? I would put it mostly on the teacher. What kind of teacher gives a textbook to a student without opening that textbook first and having a look and making sure that that is what we want our students to learn? Just because you have a textbook doesn't mean you're going to have a great result. It matters who wrote the textbook and what's in there. So have a look. And the way you do this in the AI context is you use analytics. You open it up and you look. This was a gentle example of bias. Here, your author of the textbook, me, cared more about what happens in my apartment than elsewhere. And if I were to move the cats to a different flat and try to use the same classifier, it wouldn't work. This is a gentle example. There are much rougher examples out there, as you've heard earlier in the day. What can we do about this? When the teacher opens the textbook and has a look and makes sure that this is what we want the student learning, what if the teacher has the same set of prejudices as the author? Then the teacher will say, this is fine, off we go, and we'll only discover a problem when someone down the line is hurt. So what's a way that we can do better? What's a way that we can increase our chances of catching bad things? More eyes on it first. Different people with different perspectives thinking about what are these examples that we are using to express ourselves? What could go wrong if this is what we let our systems learn? We need a diversity of perspectives here. In machine learning, in AI, diversity is a must-have. not a nice to have. That's how you're going to think carefully, really honor that question of, are these examples the ones that I want my system learning from? Because again, there are only two lines here. This objective, that data set. And if you take those two parts really seriously, that is how you are going to build a safe and effective and kind AI system. And so let's strive to amplify the intelligence of our decisions. Let's think carefully and unmagically about the examples that we're using. We're simply expressing our wishes with examples. And it's nice when we have a lot of examples. In fact, I prefer the term examples to the term data because I feel like we pronounce data with a capital D too often. This is just using examples to express our wishes. Let's wish responsibly. Let's pick our examples well. And where the system scales, let's make sure that we get a lot of perspectives on both of those questions to keep ourselves safe. So I hope that you will join me in striving for a safer and brighter AI future together. Thank you.